chat, and I'm gonna try to monitor them during the break we're gonna take, and then at the end of the presentation, I'll definitely try to answer all your questions. You can also tweet at me and ask further questions or share anything you like here, or you can follow up with me afterwards. I'll be happy to give you my contact email. So just, company harbor statement. Anything I'm going to present today, it's not intended for anything else other than just educational. And, this is the standard stuff. I have to put it. Lawyers tell me to. But the exciting stuff, here's the agenda. I told you about me. I'd love to know a little bit about yourself. We'll cover why Java and machine learning. We'll talk a little bit theory behind it of machine learning and deep learning. And then I'll show you a lot of this theory in action using live coding and demos and libraries and other tools. Then we'll wrap it up with a Q&A. And then I also have a book coming out around the same topic. And I would love to share that with you. If you're interested, I'll drop a link where you can sign up for a newsletter for this book when it comes out. So my journey has been, I started as a software engineer, Java engineer, a lot of Java EE back in the day. Then I worked in mobile frameworks at Oracle. We built a cross-platform mobile framework using Java so that you could build Android apps and iOS apps without having to write native code. You could write Java code and deploy them. So I've been in Java for a long time, and for the last about 2 or 3 years, I got interested into machine learning and deep learning. And I also, from a software engineer, I became a developer advocate 2 years ago. So I started to present externally and speak and build demos, and I enjoy doing that. When I don't do that, I also love to do magic tricks and juggling. So just so you know, who am I, and we're all in lockdown right now, so I can't be there, or we can't be in person, but I have a little poll, and please type it in the chat. I would love to know. First question is, why do you want to learn about machine learning, deep learning in Java? You can type 1, 2, or 3 based on these options. Make sure you are sending it to panelists and attendees so that we can all see your reply. This is just so I get an idea of the audience, so I can go deeper in some areas, go lighter in some areas. Wonderful, I'm getting few replies. Great, 3, 1 to 2, it's all over the place, 2 and 1, awesome. Next question, and this is the last question. What is your current level of understanding with deep learning and machine learning frameworks? 1, not at all, 2, beginner, 3, intermediate. Please, this is the second question we'll take now. Awesome, great. Thank you for your answers. It really helps me, not only with this talk, but also the larger book that I'm writing, because to understand who the audience is greatly helps. So this talk is geared for people who are fairly new to deep learning and machine learning, and perhaps are intermediate Java programmers. And they have interest in Java machine learning from a software engineering side, because that's what the focus is. So seems like those are the answers you had. So let's go to the next one. Just to give you a perspective, there's a lot of hype around AI and it's used in media a lot, but the context we're talking about is deep learning. And to appreciate what deep learning and machine learning can do, we should know a little bit about the history. So this picture is on the, let's say, the y-axis. It's showing the various type of tasks that machine learning or deep learning or AI nowadays can do very well. So natural language processing includes your, right now, let's say if I'm speaking and AI could auto-generate subtitles, right? Or you can run a sentiment analysis, what the world is thinking, let's say about elections coming up in US, based on Twitter data. So that would be a task around natural language processing or NLP. It's called unstructured data because text, when I'm speaking or when you're checking tweets, these aren't really very structured data. They can have emojis, they can have different formats, different languages, not perfect English. So it's called unstructured data. And deep learning is really good, and machine learning with training the model with a lot of these examples and then running some kind of prediction around it. Another type of data set is pictures or videos. And what we can do is computer vision. So very common example is detecting, image detection, detecting things in the image or features in the image, like face, for example, here, or a background, maybe blurring the background. And you'll see in Google Hangout as a cool feature where it can blur your background. How does it do that? Of course, using computer vision, and they probably have a little machine learning model running on your browser. And then if you can do it on the picture, you can also do it on the video. And then there are many other fancy computer vision models which can generate images called GANs, or some other even advanced ones called deep fakes that can generate fake picture of fake people that don't exist in the world, but they look just like real people. And then, of course, you can also do pattern recognition. So you can do recognition of, let's say, of COVID-19 data for every country, and we can create a model that predicts what would it be like in next 6 months, the situation, right? Everybody's very interested. And I'm sure organizations and institutes are using machine learning to, do some kind of modeling for the current pandemic. And then there are other things called reasoning, optimization. These are fairly new fields in deep learning. They are old AI fields. So the AI evolution is now on the x-axis. Earlier back in the day, we used to call it rule-based systems or good old-fashioned AI. And that lasted for a good while and it showed some result. It still is used today in some situations, but now because of computing resource availability, right? You can rent a high-end GPU NVIDIA machine, let's say on the cloud, and you can run the model and only pay for the use, let's say for 1 hour, versus paying millions of dollars to buy the machine, right? And also because data explosion, there's so much data in the world out there, both unstructured data, structured data, mostly unstructured data. And deep learning is really good at taking all this data and then you train the model. So supervised learning is where let's say I show a lot of, let's say this screenshots of me talking, right now it's dark here, or during the daytime or on my phone. And then the model will be able to detect my face in different contexts when I'm speaking. But so there is a distinction I'd like to make here between machine learning and deep learning. Machine learning is a statistical based or mathematical based, well, it's all mathematics, but it's more statistical approach to model creation and model training. Deep learning is also using similar ideas, but it's less about the old school like statistical models, but more around big data models. So The main takeaway, and happy to answer questions if you put them in the chat or Q&A. Main takeaway is that deep learning is a subset of machine learning, and machine learning may or may not include deep learning, but deep learning definitely is a technology where you hear, which is the most popular one right now, because all you need to do is provide it a lot of data, and then you can train the model, and that is called supervised learning. Or you can do unsupervised learning, where the model detects the features itself. That is really what the modern deep learning is, where the model is finding the features and you don't have to supervise it. It automatically figures out the features from your data set, important things, and then you can train it to find particular features. So again, an image, it could be a face, or it could be expression in the face, smile, or something like that. And this is going to go on, and the goal is to make a general intelligence, general AI, they call it, right? These companies, OpenAI, and their big visions around that. Will that happen? Who knows? But I know that AI is a revolution that's happening, and I'm sure that's why you're here. And being Java developers, you're at a great position to take advantage of that. So I already talked a lot, but here is more distinction. So like I said, deep learning is data heavy. If you have a lot of data, the better your deep learning model will be. Not enough data, not such a great model. You can still get an AI model, but perhaps using machine learning techniques. And often it requires GPU, may not, but it's faster if you train on GPU. Machine learning models you can train on CPU. They're not as heavy or as data hungry. I also talked a little bit about this, but these are some acronyms and terms that are used and thrown around. So supervised learning is basically at a very high level. You can think of a problem of classification, or even clustering can be a supervised problem, and regression. So classification is very simple, where you categorize different types of results. So is this result of the model, is it a fraud transaction or not? Is it a spam email or not? Or is this image a dog, a cat, a person? Very common. A similar problem would be clustering. And by the way, right now it's putting this graphic under unsupervised, but clustering can also be supervised or unsupervised actually. Clustering would be looking at a bunch of data and finding common patterns around it. So images could be, are there human beings? So it could be, boy, girl, any, older person, younger person, and you can cluster. So classes would be, is it a man? Is it a woman? Is it a young person, old person? Clustering would be, it clusters all of those together. You're finding the images by cluster. Or in biology, very common could be, you can train X-ray images to detect for the lung where it has coronavirus or not infected. And you can do that because generally in biology, the cells would form a cluster in part of a lung that would be infected. And you can train the model to say, when you see these type of clusters, that means there's a virus. And then when you have trained model, then you can run that in new type of X-ray images. Dimensionality reduction is basically a term that is used when a model has many features. So for example, X-ray images, let's take, and it has various type of cells, it has various type of information about human biology, lung, but we're only interested in very certain section of the image. So we're reducing the dimensions of the input feature vector. So the images have many interesting features, but we're only looking at certain things. So we call it reducing the dimensionality so that we can solve that problem effectively. Regression is more a problem around, or regression is an approach for classic machine learning would be detecting the price of house, what would be in your region, in your area, or rent, how much would your house go for rent next year or in 5 years time. And generally you plot that in an XY graph. So this is, you can do it, generally you do it using machine learning techniques, but you can also use deep learning to do regression. And the example I'm giving is called a linear regression. So with increase in time, let's say in x-axis, what would be the increase in price in the y-axis? And you can create a plot. Or you can predict some other kind of score. But the key takeaway is that one variable affects the outcome of the other variable. One is dependent on the other. So time will affect the price. And then there is reinforcement learning, which is a different type of deep learning where you are reinforcing an AI agent. Very common, is used in games. You probably saw example of Go by this company OpenAI. They created AI agent called for playing Go or chess that teaches itself and teaches by learning from a lot of data set from professional Go players, or it plays, it generates data set by playing more and more against itself. And when the AI agent is learning from the surrounding, when it's getting real-time feedback, that technique is referred as reinforcement learning. And there are many other things that go inside of it, but we won't talk about that today. I just wanted to paint the picture at high level. And I'm going a little bit slowly because we have a lot of time today. So this is what I call the modern machine learning pipeline. This is what the industry likes to call it. I like to think of it as a life cycle. So if you look at this graph, it's right now it looks like a linear pipeline, but I want you to think of it as a life cycle, as a software life cycle, as a graph, because what it is showing is creating a model and then evaluating it, experimenting with it, putting it in production, testing it, deploying it, and observing it. As if these things happen one by one, and once you do it, you're done. But that's not true. As you can see, the arrow comes back from monitoring back to model building. Basically, what happens is when you put a model out in production, you deploy the model. After some time, the model performance degrades. The AI prediction quality doesn't remain very high because AI is used in real world, and the world is often changing. We get new outcomes, so you have to train the model again or use a better model. So it's kind of like continuous integration in software. So that's why the arrow comes back. So oftentimes they call it model. You have either multiple models, or you would refresh the model, train it, improve its performance, and deploy it again. And then there are three essential things with any kind of ML problem, right? There is the code, there is the data, and the result is what you're trying to create as a model, right? And the model is kind of combination of data and code, but it's also its own thing. And the model can be deployed on the cloud. That's the ideal place to deploy it, so that anybody can access it over a REST API. Or you can deploy it on premise if you so choose to. But it's much easier because you can because of cloud computing. So any questions here, I'd be happy to answer. I'll go through these steps. We'll cover them in more detail when I walk through the examples. But the first thing to remember is there are key questions to ask yourself, especially with deep learning, because deep learning is like a hammer. It's a powerful tool, but you cannot use a hammer for everything, right? You cannot use that tool for doing all kind of jobs. It's a very expensive tool. So a lot of times the problem we're trying to solve can be solved with simple machine learning. That's the one takeaway I'd like you to remember, versus using deep learning. And oftentimes, even without machine learning, you can write rules, nothing wrong with writing rules if it can solve your business problem for your system. And, you can, however effectively you can solve your problem. So you really have to think about, do you have the right data set? Is it a problem of, large unstructured data perhaps, where it's hard to write rules, but it's better to train it by just throwing a lot of data at it? Did you have are there pre-trained models out there that you can use? So you skip the first few steps, because if you can grab, and these days there are a lot of pre-trained model that you can download, and what they call it, you can do retraining. So for example, if there's a model with images that can do image detection, but for example, let's say your company makes, I don't know, it makes, let's say, reading glasses, and you want to deploy this model that can detect various type of reading glasses that your company makes. So you can train this large image recognition model, the last layer, we call it. The last layer, you retrain the model with just those type of images that you care about, these reading glasses. And then the model is pretty good, because the previous layers, it helps the model figure out other features. But the last layer, it kind of really helps the model figure out what you care about, the final features. So it's called transfer learning. It's very common use of leveraging models trained by other companies and open source software. So the big question here is, there are two types of people. Let's say in the machine learning world, there are people who are building the model, right? Who are doing the data science. And there are second type of people, which are my kind of people, hopefully you guys are interested in, which are the engineers, and they are interested in machine learning. So if you play the role of, if you're interested in building the model, reading papers that are coming out, training the model and that kind of stuff, then data scientist is the new current job title of those people. You should look into that. I'm not going to talk about that. This talk is more around the second half, where let's say a data scientist in your team, or you grab the model, pre-trained model, like I said, and you want to deploy it in production in your company, solve your business problem. And you can, like we said, you can do transfer learning, or you can work with data scientists in your team if you have them. And then there is also a subset called data engineers, because the first half, the data science, a lot of the, huge part of data scientists is actually wrangling and getting the right type of data and cleaning the data, because getting the data out of your system, out of databases, that's a whole another topic. There are many technologies for that. Industry term is called data lake. You create a data lake where a lot of this unstructured data lives, perhaps both mix of structured and unstructured data. And it can come out of database, it can come out of logs, it can come out of all kind of places. And then the data scientist, grabs data from the data lake, and there's a whole pipeline for that. So if you're interested in that, you can check out various services that we offer in our cloud. Through Oracle Cloud Infrastructure, we have various services that can help you with data engineering or data science. For data scientists, we have we bought this company a few years ago called datascience.org. It's become part of Oracle Data Science platform, where you have these hosted notebooks, and you can connect to data lakes, and you can run Apache Spark queries or TensorFlow on these notebooks using Python or R, and you can connect them to Oracle databases and all kind of stuff. Just wanted to put that out there. If you're interested in that, we have a lot of those services. But if you're interested in machine learning engineering side of things, Like I already mentioned, machine learning engineer is kind of like a new role. And on the left side, it's a recent tweet I took like 2 days ago by this girl, Chip. And she is very popular on Twitter, as you can see. She talks about machine learning in production, or ML ops is the new word. And she said, machine learning engineering is 10% machine learning and 90% engineering. So should be good news to software engineers, because what that means, one, it's a new job these days, very hot, and the most skills that it require are really software engineering skills, because like I said, it's about putting machine learning models in production and just essentially kind of knowing how to use pre-trained model, perhaps how to uh, retrain them, and then how to deploy them and maintain them. That's a big part. So in a cloud environment, the job of an engineer kind of has become like you're also doing DevOps, right? Because you're configuring things in the cloud. You're also writing code, which is a software engineer job. Machine learning, you need to know about these libraries, a little bit about data science, not being expert. So that's what this is, the hybrid, and that's why it's hard to find these people. So they're in high demand. So I hope motivates you and the talk to, because why Java is probably a good place to answer that question here. So Java is number one programming language. It came out in the survey earlier this year by various third-party surveys, especially in enterprise setting. So in enterprise, if you think of large businesses, Java dominates. Just in Silicon Valley, I have friends who work at LinkedIn, Netflix, Twitter, Google, even people at Apple. Their majority of their backend is written in Java. So their systems, when the systems are in Java, then these people are looking, the companies, the business leaders, if they can solve the problem using AI within their existing infrastructure versus having to build another infrastructure around Python, let's say. It's much more effective to build it around Java, because Java is a large ecosystem. It has a lot of libraries. And now we have these thing called cloud native Java, where you can run Java on the cloud, much lightweight Java projects using microservices and whatnot. So it makes really interesting. And I'll talk about that in more detail. So I mentioned this word cloud native development. And if we were in person, I would ask you how many people know what cloud native is. Cloud native is a term. Basically what it means is being able to run your applications on the cloud. So the applications are architected for the cloud environment. What is cloud? Unique thing about cloud, we call it horizontal scaling. So horizontal scaling means if you used Oracle Cloud, let's say you get one compute, right? One small VM. And if your application demand grows, and you can grab another VM, right? The small ones, they don't cost very much, and you can get more and more and more, and all of them can work together, and you can orchestrate them using something called Kubernetes, where you orchestrate different containers that are running inside of these VMs, right? The CPUs, virtual CPUs or GPUs. So cloud native, there are various type of tools that help with this. Docker is one, microservices is another thing, Kubernetes is another thing, right? And they allow for basically horizontal scaling and ease of deployment. Different teams can use different technologies, and they can talk to each other. Versus in the old days, I remember like we would check out a large Java project from SVN, and it would take a few hours, and then it would take a few hours to build it. And then every time I make a code change, I'm changing few files, but my IDE, it has all these hundreds of files, right? And I don't want to touch any of the other code, because it's like, I don't know if I break something. But if you, and we call that monolithic application, and I'm sure you might familiar with it. And it's still, there in enterprises. And most of them are written in Java, enterprise Java frameworks. But deploying that in the cloud is not very effective or efficient. So the new architecture is called microservices, where you break the giant monolithic app into microservices, and you can deploy different microservices. So microservices, for example, would be, so let's say, think of facebook.com, right? You go to Facebook. Now Facebook website has many features, right? It has a news feed, it has finding friends, it has a chat, right? It has messaging. Now, if this was one giant monolithic app, it would be one large code base with various classes to do various different things, right? And probably that's how it was back in the day, like when it was written in PHP or something like that. But a modern, I'm not speaking, I don't work at Facebook, I haven't worked there, but I'm just guessing this from what I read in the industry and what I see some of my friends. So a lot of these companies now, they don't use one technology, they might be using multiple technology. So the backend, let's say Twitter, I know a lot of their backend is written in Scala, Java, because of performance reasons, right? But their front end might be in, Ruby on Rails, partly JavaScript. Now, one of the feature could be written in Ruby, other could be in JavaScript, could back in large amount caching could be in Java. All of these things can talk to each other over RESTful APIs. So now when you are working on the code, it doesn't have to be this full app. You can git clone only part of the repository that you need to work on and your team, and you can make code changes and you can talk to other services as well. So that's the beauty of microservices. There's a lot to be said about it, but it's the way to go in cloud computing. So what would that look like in reality? So for example, I kind of described it. So monolithic app on the right side, it's everything, the big MVC, let's say the Spring Java application, or old school Java EE application, or together. And there are some benefits to that. It's not everything is bad about monolithic. There's some good use cases, but having a lightweight microservices lets the team move faster. They can use best of technologies. And these microservices can run independently and yet be connected. But it does create a little bit more complexity in the code, microservice architecture. And simple application, perhaps simple use cases don't need microservice. They could be one big application. So there are a few things. I have linked a few things here in my talk. I would encourage you to read more about it. You can ask me questions, I'll answer them. But everything in microservice is accessible over a REST endpoint. So for example, in the right table here, it's showing, slash, whatever your URL is, let's say slash last name, in parentheses, you type in the last name, and it would make a GET request to search by that last name, right, or department. And you can do all the standard RESTful methods, GET, PUT, delete, update, all of those. And different microservices would be called and triggered based on what operation you're trying to do. So what is the stuff that I like here? There are a few open source technologies. So I'm going to further divide cloud native. So cloud native application is one thing which we talked about so far, which is microservices, right? So on this here, we're seeing monolithic architecture. And on the left, I'm showing you microservice architecture. But there's another type of architecture, which is called serverless, or function as a service. And there is this open source project called FN project. And I highly recommend you check it out. It's an Apache 2.0 project. It's open source by Oracle. And it allows you to run serverless functions. You can run them locally or on the cloud. And you can create many such functions. So it's just one function, does one thing, right? But it runs on the cloud. So these are really great for machine learning use cases, I feel, because you may only need in your, let's say in your business app, you may only need to do machine learning for certain thing. Let's say when somebody types a text and you want to run some kind of machine learning model on that, or they upload an image and you want to run some kind of machine learning model on that. And to have a whole microservice application, maybe too much. You could do that, it depends on use cases, but it's much, I feel, effective to just have one function that does that model inferencing. It runs the model and it gives the prediction on whatever data set you want to run on. And you can have multiple such functions, and they can be used for all kind of jobs. On the right side is cloud native app, not a monolithic app, but cloud native app, which where you have microservices. And the microservices could be for your business logic or machine learning logic. And they are open source frameworks for Java developers. Two of them very popular, called Micronaut and Helidon. Helidon came out of Oracle. Micronaut is from the community. It's the leader right now. And you should check them out. They're very exciting, cool, and they make writing Java, server-side Java code fun again. And then the FN function project is open source, so you can run it anywhere. But at Oracle, we also have called Oracle Cloud Function, where you can run these functions. So again, what would this look like? So like I said, these are all endpoints. The microservices or the serverless functions, they're accessible on these endpoints, right? URI endpoints to REST. And they can be for images or text or any other purpose, or even for model deployment, model management. Remember, these are part of the machine learning engineer. You want to, have what companies call model zoo. Let's say the application is not performing. You want to swap the model for this model to a different kind of model, or a different version number of it, or deploy somewhere else, or run QA testing. So you need a list of services that help you with model management and deployment as well. And all accessible over RESTful. So what is the current state? Now we're finally getting into the more interesting stuff. And we're also coming up on the 45-minute mark. So we're going to take a little bit break. And after the break, we're going to dive more into the deep learning, these libraries. But I'm going to give you, we'll start the journey. So when I say TensorFlow or PyTorch, most likely you probably, if you didn't know earlier, you would not think of Java, right? You would think of Python. But the exciting news is that both of these libraries, these are top 2 libraries for doing deep learning right now. And they all have Java implementations in various forms. TensorFlow library has its own special interest group called SIG. I'm a member of that. And they just released TensorFlow for Java version 0.2.0, which is very exciting. It's not 1.0 TensorFlow for Java, but it is something that allows you now to train your models using TensorFlow in Java and use it for deployment or inferencing. It doesn't have all the bells and whistles of Python, but they are coming. There's active work happening, and you're welcome to contribute. And I've put links to those things. Maybe I'll just show you. So go to a GitHub. Actually, this goes to the main page, Google's page here. But all of this, actually, let me show you. TensorFlow, Java. Go to my GitHub. So this is from TensorFlow Java model that I forked, where we have examples to do various type of operations. Mostly these examples are around computer vision. And for computer vision problems, we call them CNN models. And these are different type of model. and this one is doing something called MNIST, which is it's a very classic machine learning problem where you detect images. And so it looks at images and it tells you what type of image it is, what type of, basically these images are handwriting recognition from 1 to 10. Very simple, but you can do handwriting recognition using MNIST. MNIST is the name of the data set. So this is where you train the model. I'll walk through these things later, but it's showing you in your Java code where you can run, we're running TensorFlow APIs here to do all of the stuff that you would do in Python, but you can do in Java. You can train the model and test it and do all sort of stuff. So I'm gonna just go over here and let's go to Carl. He is I know these people because they are the ones, they are working. I want to show you the TensorFlow Java repository. There you go. So this is the one, this is what you want to use. It's at version 0.2.0, just came out a few days ago, like I said. And it has TensorFlow core. These are the core operations of TensorFlow framework. These are work in progress, higher level APIs called Keras. It makes working with TensorFlow fairly easy because it's at a higher level. And this is all in Java, but it's mapped to the Python Keras APIs. And there is something called ND-array, which allows you to create tensors. It's a data structure for n-dimensional arrays. And you can install and run all of this through Maven. So it comes with the POM XML file. And this is how you essentially install it. In your POM XML file, you add this dependency. And this is for, for whatever platform you're running it on. If you have a GPU-powered machine, then you can also enable that. That will allow you to run it on a GPU much faster. Otherwise, you can run it locally on your CPU, like I'm running it. I'll show you examples a little bit. But yeah, it's very exciting. And this is the Java version. It maps to the main TensorFlow version. So TensorFlow is right now 2.3.1. This is what this Java version maps to. Okay, so, and you're welcome to join, email these people if you have any questions. We're all in the SIG, and you can also come to the meetings. You can also contribute, help. There are a lot of issues. You can fix bugs, help Java community by contributing to this project. This is a really cool project and very active work happening. Another project is PyTorch for Java. So another very popular library, PyTorch, right? But believe it or not, PyTorch Java binding exists, meaning that you can use PyTorch right here. There's a very simple example where they are, it's not very interesting. It creates this model. It shows you how you can save data like a tensor using PyTorch API, and you can make queries to that. And it's called, this is the data set. It has 6 integers, not very interesting. It's 2 by 3. This is the shape, 2 rows, 3 columns. So, but what it's showing you is that there are people who are porting these libraries either through community or somebody, this person, I think they work at Facebook themselves, who created this library. And it's all on GitHub, so you're welcome to, like I forked it, I'm playing with it. I might make some contribution to improve, some of the things here. But it shows you that you can run PyTorch models in Java using PyTorch for Java, this library. Or models trained in Torch script, which is a C++ of PyTorch. So that's very exciting. The downside is that it's lacking documentation. It's only good for inferencing. So it doesn't have the ability to do training, this library, PyTorch for Java. So you would If you want to do training or retraining, you would have to do it in Python, PyTorch, but you can use it for inference, right? You can put it in deployment. TensorFlow for Java, it allows you to do both. Another interesting library is called DJL by Amazon Labs. It is another high-level APIs that work with different engines. They call it engine, meaning basically, I'll show you examples of this after a break, but you can use DJL that can talk to PyTorch or TensorFlow or MXNet. So you can think of it as a higher level layer, and it can talk to other libraries. Another interesting project that we released, I helped with that, called Tribu. It came out of Oracle Labs. This is also another Apache 2.0 project that is a library that lets you do machine learning in Java. Very common problems like what I talked earlier. And there's a very popular library in Python in machine learning community called scikit-learn. And what Tribu is doing, it's an alternate. So what you can do in scikit-learn, you can do it in Tribu using Java, because for Java developers. And this is how you install it, Maven or Gradle. You can clone the repo from GitHub. It has a lot of examples, so I recommend you check that out. There was a session earlier today, I don't know if some of you attended, by my friend Manny, who talked about Tribu in depth. I'm not going to go in depth in that. We'll cover more the deep learning libraries, mostly TensorFlow and DJL. Another library that has been around for a while called DL4J. It's part of Eclipse Foundation now. It is also, it's kind of heavy duty. It can do a lot. It has support for, Scala, Java, Kotlin, and it has a lot of interesting examples. And it is pretty heavy duty. There was a lot of active work happening here, but I don't know what the situation is right now. But it is now part of Eclipse, another open source. It's a very interesting library. I recommend you check it out. You can do even including Spark queries. But I found it a little bit hard, complicated. I like these little bit lightweight, like TensorFlow for Java or DJL more. But what the takeaway is here, there are many libraries to do machine learning. All the stuff that you wanted to do, you can do in Python, you can do in Java too. All the cool hard examples, problems you want to solve. And there's active work going on in open source around these things that will allow you to not only deploy, but also do the training like a data scientist in Java, if you choose to. And you can also do it using notebooks. So I'll talk about that as well. I think we've talked a lot. Let's do a 4-minute break. And after the break, we come back. I'm going to cover machine learning fundamentals, and then I'm going to jump in to code and show you these libraries in Java code demos with machine learning. And you can drop some questions for me, but let's take a break. It's 6:20 a.m. my time. Let's come back at 6:24 a.m. We'll start at 6:25. So just take a 4-minute break and be right back. A lot of exciting stuff to cover. Thank you.
Thank you for your presentation till now. Would you like me to put the clock or the timer, or just we will wait another 5 minutes? We are back, and now I will stop sharing my screen.
Thank you very much. I will welcome back, everyone. I hope you're still here and excited. We're going to now go deeper into the world of machine learning in Java. And I also want to just give a quick thanks to the organizers of Make It Conference for having this wonderful conference virtually for all of us to learn about all these exciting technologies. And I hope you're getting a lot out of the day's session so far. So and anytime, I'm not seeing any questions, but please drop in anything. I don't think I'm explaining you everything perfectly. So any questions you have, any comments, just ask me anytime, and I'll go into those things. So what is in machine learning? To think about is that what we are creating is creating a network, and a network is called the word is deep learning or deep neural network, right? And a network is visually, if you think about it, it looks something like this. It's a graph, and in the computer science graph, as you probably know, graph has edges, right? These circles, and it has nodes, or the nodes are the circles, and edges are the arrows. And there is a computation happening in each of these nodes, right? And that's what happens in machine learning too, or not in machine learning, in neural networks or deep neural networks. So again, I don't want to confuse anyone. So deep learning is a subset of machine learning, and neural networks are also a subset of machine learning. Machine learning can have different type of models, but the most common type of model nowadays are neural networks and deep neural networks. So here where it says hidden, these are the layers we call hidden layers. Right now it has 2 hidden layers, one input layer with 4 circles, meaning 4 input features, and 1 output feature. So for example, we could provide it 4 different type of images, and the output prediction could be which one is a human being, like the CAPTCHA, right? Sometimes you have to fill out the CAPTCHA, right? Where you log in and it shows you, hey, which is the traffic light? And you have to click certain things. Now you can train a model by showing a lot of these examples and saying the CAPTCHA we are looking for is person's face. And the model will tell, okay, this one has it, this one doesn't. So it's in this case, a directed graph. Arrows are directed. And actually, the direction can go forward and backward. So it's very common. Right now, I said it's not showing back propagation, but it's also very common algorithm where the computation flow goes from input towards hidden layers and towards output, but it also goes back and forward multiple times. And when it goes back, it's called back propagation. And what it does, it further improves the network and the parameters in the network. So these things are called hidden layers because generally we're not interested, I should say, or we don't care so much about what the model is doing inside of it. But what we care about is the result, the output, the prediction, and how effective it is. And to measure that, we have something called loss function. So you train the model in various iterations or batches, which means like a giant loop. Put a lot of data and you split the data to keep training the model again and again. And every time, in every iteration, various type of computation happens, all the way from input to the output. And output is a prediction, which is a score the model gives you. So if I'm looking for hamburger, it won't say this is a hamburger. It would say it's a hamburger and the prediction is 45% or 95%. That would be the score. Label would be the hamburger. And in the input, I have to provide many images, some hamburgers, some pizza, some coffee, so images and label, right? And that's the difference between traditional programming, where we just write logic, right? If I was to write old school like rule-based system, I would take an input and I would run some kind of graphics program to parse through each pixel and detect if, this pixel is at this position, and then at this position, maybe it's circular, and then I can see it has slices. Oh, okay, it's like a pizza, right? It would be a very complicated program, and maybe may break for certain type of images. And that's why deep learning is interesting, because we don't have to write hand code all those rules in that program. We let the model figure out the rules, and that's the magic. And this happens in these multiple layers. The model is kind of figuring out, learning. It's learning on its own, based on a lot of input. And this is an example of supervised machine learning. So that's the interesting stuff. So we're more interested in tuning the model, improving its accuracy, and the loss function. And then we use some algorithms. There are some optimizers, an activation function. And I won't go into much detail of that, because then we're talking more on the data scientist language. I want to keep it more on the engineering side. So here are high-level steps. First, you have to define the neural network. So what you're going to work with this graph, and you're going to create this neural network, right? And that's how. So when you look at these APIs, TensorFlow or PyTorch, that's what they're giving you, access to this network, and these classes that access to these tensors or ND array and these objects. So it's important to understand what do you use them for. So first step generally is you create the network and has some parameters or weights. You assign some weights to the input. And then you iterate over these input features of this data set that you're providing. And then you process through this input. You apply activation function and optimization to that, and you compute a loss. Loss is like, basically, loss is generally shown as a graph that trend downwards, meaning as you're training more and more, the accuracy is improving and the loss is going down. So that's why we say the model is like at 95% accuracy or 50%, because you can see the loss, the curve, how it's plotting. And an algorithm that is used to do that, it's called gradient descent and back propagation. And what they're actually doing is they're updating the model, its parameters, weights, until it fits, until it gives accurate prediction. So it's not overtrained or undertrained. So training, you can train too much with the same type of data, and that is called overtraining. Or you can undertrain the model, where you don't have enough data, enough examples, and you think you have a good model, and you put it in production and it fails because it's undertrained. So there is something called model fit, where you have to balance those two. And this is more, it's like almost an art and a science. Again, these are some things I'm talking more in data science language, but it's good to know some of these things. So the example, I won't go too much into this, because again, this is going more into the data science of things. But this is, if I talk about regression model, the thing is called fitting the curve, or fitting the red line. So what we are trying to do is, we have a lot of these data sets, and those are blue dots, and and if you map them in a graph, they are all over the place. And the model, what our model is doing, it creates graphically, if you think about it, it has this red line, and what we're trying to do is create this line such that it touches, or it gets close to as possible to all the data sets. It covers all the data points. So in a simple linear regression model, it would be a straight line, and the straight line is defined in this equation called y equals to mx plus c. And here, the y, we have the y-axis is our output or prediction, x-axis is our input, and weights are the parameters, or the adjustable, or in machine learning term we also call biases in the data. So x could be, let's say, again, it could be the housing price problem. X could be the price, or x would be time, and y would be the price. So over time, what the price would be, and that's what we have plotted here. Let's say we have the data for last 10 years, and we want to make a prediction for next 10 years. Then we would create this regression model, and this line or this model is trying to be as close as possible to the predictions. For the farther away it is, less accurate it is. So it's also called fitting the curve. So right now it's a line, but it could be a curve. And we say fitting the curve because we want to try to fit the curve to match as many points as possible. And so don't look at the left side. Let's look at the right side first. So the problem could be linear problem, like I said. It could be a regression problem where it's price over time, or it could be a classification problem. You run a credit card, you're a bank, and you want to find out, is this credit card transaction legitimate, or is this fraud? Is it stolen? Is it coming from somewhere else or not? Right? And that would be a classification problem, and you can create a model for that, very simple. Or you can do a clustering. Okay, there are like 50 transactions this month. How many transactions were done in the location where this customer lives? Okay, these many. So most likely these are all legitimate, right? And how many transactions were done where this person doesn't live? Oh, okay. Some from this state, from this state. Oh, maybe somebody stole the card. So just giving you examples, but that would be a clustering. So you can solve these problems. Now, how the model operates is a very common algorithm. It's called gradient descent. And basically what the model is doing is gradient descent is defined as if you're at a mountain or a hill and you want to descend, you're descending down, you want to find the most optimum way, optimum steps to take to come down from a hill so that you come to the lowest minima or the lowest minimum point without like walking on another hill, right? And you want to do that in as less time as possible. So that's why you have to take, each step you're going down, and then as you're correcting the steps, think of adjusting the weights of the model. And when you're at the lowest point, lowest minima, then the model has performed at very accurate, high accuracy at lowest cost. So that's an analogy to think what gradient descent does. That's what it does. It trains the model, keeps training it until the model is performing very well and the loss function or the cost function has gone down. And while it's taking these steps, it's adjusting the weights. So in TensorFlow, this is kind of like the flow chart of it. So you read the data, you have two things, a Keras API or TensorFlow API, and you can train it on a CPU, GPU, other places. And then you get a saved model. A saved model is a type of model format. TensorFlow models, when you download from GitHub or anywhere else, they can be two types, the saved model or the frozen model. Saved model is this model that's been trained, and now we can deploy that in various places. So we can do it in Python, or like I said, you can also do training in Java now with this library, TensorFlow for Java. Earlier, it was only for deployment, but now I should update this slide. It also allows you to do training. So you can do the whole training in Java itself. It's very new, but in this slide, I'm showing that you can deploy the model that, let's say, your data scientist trained or pre-trained model using Java APIs in production. Or TensorFlow also has models you can deploy in JavaScript or other languages. So this is the open source project. I talked about it, so I'm going to skip over this. My friend and colleague from Oracle, Adam, works there. He's also a maintainer of Tribune library, and this was the comment he made. So let's look at live demos as I promised. So first thing first, I want to show you, I'm thinking which one to show you first. Let's go with TensorFlow. So tell me, somebody can tell me if my code is visible. Is it too small? Should I make it big? Is it okay size? Maybe you can type in chat. Is the size okay? Font visible, everything you can see? I'm going to walk through this. Okay, great. Thank you. So this project, it has, let's look at the first very simple example. This is hello TensorFlow, right? Because we want to write a hello world program. And what I'm doing is I'm importing these libraries or these classes that gives me TensorFlow in Java. And let's look at the POM XML file. So it's a very simple Maven project where I'm executing the hello TensorFlow class, and and I have a couple of dependencies. I have two dependencies here. One, I'm using TensorFlow 1.15. This is a slightly older version of TensorFlow for Java I'm using, but it's the one I'm most familiar with. So we're gonna use that, and I also have another dependency called Helidon. Helidon, I talked about it earlier, so I'm gonna mix the two ideas now: cloud native computing and TensorFlow for Java. Okay, so this is the program that it's not very interesting. Like I said, it initializes the graph first. The graph is where everything happens. It's a TensorFlow graph, like we saw the neural network. And in this graph, we create a tensor object. And basically, we're not doing very interesting, we're doing very simple operations here. We're grabbing a constant. Basically, we are getting the version of this TensorFlow. We're printing in string what this TensorFlow, the output would be the version, print me the version of this library TensorFlow we're using. And we create a session in this graph. Everything in TensorFlow, all the operations, generally they happen inside this thing called a session. So all of these, we throw them inside a try catch block, because that's the good way to do it. And I am just going to, so to run this code, I'm going to create, I could run it here locally, but I wanted to show you how you would do it on the cloud. So I'm using Helidon, which is an open source cloud native project. And what I've here done is, again, I've imported the various classes that I need. I need very simple things. I need a I'm going to create a web server. So I need web server, and I need to do routing. So here, so we instantiate TensorFlow, but the interesting thing is I create an instance of the web server, and it uses these APIs. This basically, essentially, this routing. We need to create a router. Router means when we go to localhost, whatever port number it's available, it's going to find that, let's say 8080, and you go and you have slash the URL endpoint, slash could be whatever, API name or something like that. But we're going to handle the default route. So just localhost 8080. And what we want to do is there we want to display or we want to return, I should say, uh, we want to send a response to the client. In this case would be the browser with a string, and the string would be prediction. And the prediction is on this object TensorFlow, and I call TensorFlow run TensorFlow, and it executes this function inside TensorFlow, and basically returns us the prediction. And it's not something very interesting, but it makes the point. So let's just run this code inside Visual Studio. So as you can see, it's running at localhost 5193. I'm just going to go there, and this is hello from 1.15. Basically, what it just did is it just printed on our localhost. Not really a prediction, but right now I'm printing a version of the TensorFlow library. And this is being returned from the TensorFlow for Java code. But I could as easily, I'm just showing you what you would do when you create an app. You could return a prediction. You can make a GET request and send your data, text or images, whatever, as JSON, and it would return you the JSON response, and you can print that or do whatever you want to do on the client side. So this example is very simple. This is because it's best to start with simple to show you how to use Hello DOM microservice and how to, and then you can create other service. So this is one service. We can write another service. We're not gonna do that right now, but we could we could write ML image recognition service or something, and this thing would handle, like, it can take an image that you send from the client and it can return the prediction of what this machine learning model thing, this image is, the label. It will give you that, and it give you the score of that. So oops, I'm gonna save. Yeah, I'm gonna not save this for now, but I want to show you another example. This is slightly more interesting of TensorFlow. Here we're gonna use an image. We have some test images, and we're gonna use this image of this whale. So for example, let's say your app, you want to detect, you go to someplace and you take a lot of photo. Let's say you go in the ocean on the cruise and you want to take photos and you want to know what kind of animal is this. And with these fishes, we don't generally see them completely. They are underwater, they're going around. So you take a photo and you're not sure this is a whale or this is a shark or what is this. So we can build a model by grabbing a pre-trained image recognition model, like I'm doing in this case. I'm grabbing a model called Inception, and it's a very popular model. It's not a huge, big model. It's a lightweight model relatively, and it is trained on various images. So this model is a TensorFlow frozen graph, and it's open source licensed in Apache 2.0, so free to use it. And the model, when you download it from the internet, it gives you two things. The PB file, this is a binary file. It's a TensorFlow model format, and it gives you a label. So you know what this model is trained to detect. So it can detect all these type of things. And I'm sure we can find a whale here. So it can detect a gray whale, actually two different type of whale, killer whale, and it can detect all these other animals. So what we're gonna do is we're gonna pass an image, this test image of this whale, and we're just gonna use this model as inference. So let's say we had a web app, and in the web app, anybody could upload the image, and we're gonna run the model to infer, okay? So let me walk this code a little bit with you. So at the start, I have my main method here, and I'm going to take two arguments. For the first argument, we're going to look for where this model lives, the directory of the model. Now, this is right now a local machine, but it could be on the cloud. I could grab this model from, let's say, Oracle Cloud. The model, generally, I would store it in object storage. Cheap storage for this type of data unstructured, and I can put this model on object storage. I can grab it, and this program I'm running locally, but I could run it on, Oracle Cloud Compute, right? And in whatever environment, like in the Ubuntu environment. So the second argument we want to grab right now, because we're doing it locally, I'm passing it through the command line, but these might as well come through your REST, your post request. So the image file is the second argument, and what I'm going to do is basically there is some helper code here that is parsing the images, converting into a byte serialized format, because these are in different format, but the Java program need the data to be in a byte array. We do have the labels that we're going to bring this file in and load it as a list of strings, and then basically I'm going to process the image as well. So I'm going to grab the image also. I want to grab it as image bytes, right? The image file converted into an array of bytes, and then we need to define the probabilities, because like I said, the prediction is a score, or you can think of it as a probability. And when you provide the images to the graph, it returns the score of that label. And then we're going to print the score that is the most highest probability. We're going to print that. And we're going to say best matching score for this image is this label out of this file, which is the highest ranking score for that image. Okay. Here there are some helper methods where we normalize the images. So basically, there's something important to know. This model is trained on images of dimension 224 by 224 pixel. So when we upload the image, we want to make sure we send this image to the model that it's also in the same format, an RGB image with 224 by 224 height and width. Okay, that's important because that's how the model expects the input to be. And then this is data manipulation, decoding the image. The interesting thing happens inside this try block, where we start the graph session of the training session. We call the runner, fetch, and then we do various type of operations. And basically we grab the output of the model, the first one, which is a class, and then basically it's our prediction. And another helper method here is this is where the execution of the graph happens. So this is where the inference, this is the real heart of the code actually. So we start the graph session. We instantiate the graph. We bring the graph definition that we have defined above, right here, the pre-trained model. And then we start the training session here. And in the training session, this is where we feed the input. Remember, like I showed you, the circles, the input in our case is the image. And we want to grab the output at the end of the training. And output, this is for different purpose. This is the output where we are grabbing the prediction of the model, like the label, what image it think it is. And There are some other helper functions here where we check the result, and in essence, we are what the model is also doing. The model is giving us a score of on all the, so it's not just giving us one score on one image, it's giving you what percent it think it is this thing, dummy or kid fox, or this thing, or this dog, or this thing, and this. And we were interested in the score that is the highest, the maximum value. So there's some other helper method here, but what we're interested is getting the best, the highest probability. And again, these are just some helper function to read the data, massage the data, so forth and so forth, and decode the images and blah, blah, blah. So this is, I need this, all of this, because I'm dealing with this image data. But if you're not dealing with image data, you won't have to do all of this stuff. So let's just run this program. All right. So I would. Okay. I can execute because we have the. I can run the code like this, but it's not gonna work because I haven't passed it the arguments yet. Okay. So what I'm gonna do is just make sure. Okay. So we're grabbing this class and we're compiling it. Okay, and running it. And then what we want to do is we want to, give me 1 second. I have to pass in the arguments for the first argument. The first argument is the model directory. Okay. Resources. Oops. Inception H, and the second argument is the image file. So second argument would be this, and we're gonna pass in the whale dot jpg, and now it should work. Okay, good. So it executed the code, and what it did is basically it printed the highest probability that this image that I provided it, this whale.jpg, this one is a killer whale at 41.59 likelihood, or this is the probability. Not a very high score, but this was the highest score that this model got based on this amount of all of these various output predictions. And generally what you would want to do is, as a machine learning engineer, if you grab this pre-trained model and it's not giving very high output on your data set, you would provide it more of your images and you would do retraining. So you would train the last 2 layers and you would train it until you get a high likelihood you're satisfied. That is pretty robust now. It has seen all the images of for your business, and then you can deploy that using something like this machine learning service. Okay, so I wanted, any question, just type it in. I'm going to jump in and I'm going to show you a different library now, which is, sorry, I have too many things here. Yes, this one. This is the library called DJL. It's a nice library, and basically they have, credit where credit is due. It's built by Amazon Labs, but it's an open source project, so I like it. And it's called Deep Java Library. It has abstracted TensorFlow, PyTorch, Onyx, another Java-based machine learning framework, and it runs. It can use JDK 11. One nice thing is that a lot of Java now code can be executed in form of a notebook. So let's restart this. So this is a, oh, this is a notebook called a Jupyter Notebook, and it's running on Google Cloud. Yeah, strange, right? So you can run it, on any cloud, or you can run it locally. But it's nice that they have set it up for us to run it on the cloud, and it's just starting right now. But what Jupyter Notebook is, this is how data scientists work in the Python world. It's like this web app where you see code inside these things. These things called code blocks, and there's code here. There is also text, which is like you can think of comments, and you can execute these blocks. And these blocks generally are part of code. So this is just doing something like Maven commands on this on the terminal. And here we are, this is the Java code, and we have comments, and so it's nice. What this program will do is this is MNIST data set. I mentioned this earlier. It's like a handwriting. Somebody has handwritten these things, these numbers from 0 to 9, and the program will detect them using computer vision. And when you provide a new image, it will tell you which one it is. Okay, we are, I know, running a little bit short on time, so but I really wanted to show you this. Oh, come on. Yeah, it's taking some time to run this code here. It would start like the note. It's not ready. Anyways, we'll come back to this. Let me cover in the meantime another piece of technology that is interesting for machine learning engineering. There is this library called MLflow. And so let's say you have this model, you've trained the model and you've deployed it in the cloud. Now you want to, important to do model tracking, model management. And to do all of that, to make it easy, there is this open source library called MLflow. There's another technology called GraphPipe by Oracle, which we have open sourced. But I think MLflow is at this time more interesting, and I would show you, and it has a Java client. It's a very popular tool. You can see how many GitHub stars it has in machine learning engineering community. Let's go to the website. It basically lets you monitor, deploy machine learning models. And it has support for various type of framework, all these popular frameworks. And it's open source by this company called Databricks. And the nice thing is, when we're interested is their Java client. And so it has Java APIs to be able to do various things around your model. You can create, you can call different models, you can do all kind of things. So you should have a look at this. This becomes very important when you deploy model to production. Let's see. Okay, our notebook is ready. So this is Jupyter Notebook. If you've played with Python, it's very similar. So and Jupyter is an open source project, and somebody in the open source have written the Java kernel. Kernel is what it allows it to run, because this code is running on some server, on some cloud, right, in this case. And it's not running on the browser. Browser is just the interface, but we execute it by, you can, in some notebooks there's a thing here, but we can like this, run, and it shows the star, and then when it's done, it'll tell you. Right now it's executing these commands on the server. So it says 1, that means done. Now we're going to run the second block. This should be very simple. It imports, right, various things for us, and we can go to the next block. We can prepare the MNIST data for training. Here we define the batch size. Now again, remember this is a different library. This is not TensorFlow for Java. We're using DJL. So every library has slightly different way of doing the same things. This library, first we have to define the batch. So we're giving it a batch of 32 images at a time. And we call the builder, and we provide the batch, and we call the build. This is just to load up the data. So here we're gonna run this block, and it should download the library and execute these 3 lines of code. Get ready for training, basically. Okay, that's good. Now we're gonna define the model. So we instantiate the model, and this is MLP, meaning multi-level perceptron, or deep neural network, you can think of it. In this library, they have something called blocks, which are sequential code. You can read more about it. Some documentation is defined here. And this model takes data of size 28 by 28. So the images, these images, like I said, it's important to know how the data set is designed. So this data set is trained on these images, which are 28 pixel by 28, black and white. So that's why we have to define that, that what we are also providing, this model needs to be defined with 28 by 28 images. And we're defining multiple hidden layers in this case. So let's execute this one quickly. And now we're going to define the trainer class where the training will happen. Again, this is a different way of doing it. In TensorFlow, we would create something called a graph. And here we're defining a trainer. So they have different APIs. So I'm going to execute this piece of code. And it should be pretty straightforward. This is using MX Engine. It's another framework, open source. And we're going to initialize the trainer with this shape, or shape is the tensor. 28 by 28, one input. And now we're going to start the training. Now this is where the actual training will start. Epoch is the number of training we want to do. And we're going to do the training in batches. So this is another time horizon, and this is another. We're going to train in batches. Batch we defined up earlier. And then we're going to execute the training, and we're going to print some of the stuff and to see how the training is progressing. This generally will take some time. So I'll let it run. But in the end, what you do is once it's trained, you save the model, and it would save it in this directory. And then you can download the model, and then you can run the model, which we call model inference. And you already saw me running it for images and so forth and so forth. So let's go back to the slide, because this would be taking some time, and it's running on the cloud. But all of this code, you can download it, this Jupyter notebook, and run it locally on your local host. You have to install Jupyter. It's an open source tool. Or you can run it on the cloud. Nice takeaway is that you can do Java coding using notebook style and run all of that. This is the big advantage, like Python people say, we can run, don't have to start IDE. You can do the same thing for Java now. Thanks to open source community, we have built Java kernel for Jupyter. So exciting stuff. Another exciting piece of technology to know is Onyx, ONNX, pronounced Onyx. Onyx is a platform that provides interoperability. So a lot of these, like I was showing, DJL or different MXNet, TensorFlow, PyTorch, all of these frameworks generally they have a format for saving their model. TensorFlow would be that .pb file, right? We saw. PyTorch is .dt. It's a different type of format. So generally, you cannot use one pre-trained model in another library. But what Onyx does, it allows for interoperability. So if the model is trained in one framework, using Onyx runtime library, so it's another library you have to use, it can translate that for you, and you can use it in PyTorch model and TensorFlow, or this MXNet model and TensorFlow, and these type of things. So it's very exciting. It's open source tool, and the Java runtime, it's written by Adam, who works at Oracle ML Labs. It's an open source project. Many companies are behind it. So it's also very exciting technology that allows you to use models trained in Python and other frameworks, not just in Java. And then finally, there is also something called Visual Recognition API. This is part of a JSR. It has moved to a next level now. This would allow you to, without having to install various frameworks and toolkits, to do visual recognition within Java using this VisRec API as part of this JSR 381. So this is basically what I'm trying to show you is in the open source community, exciting things are happening around Java and machine learning to make Java developers' life much easier to do, in this case, visual recognition without having to download and install fancy libraries. So I hope that helped you. We saw some code examples. We covered what machine learning, the principles are. We covered how to deploy, what architecture looks like in cloud computing. One thing I wanted to quickly show is serverless function, and how you can use that, or you can use a microservice architecture, right? So with all of this knowledge, you are free to dive deeper into these things and play with them, and then deploy and do a test project for your business, your company, and use these frameworks. They are all open source, and you can use them for your pet project to learn. And I'm writing a book, so I would love to know. Actually, we may not have time for the survey, but I would share a link to my newsletter. And I'm creating content, more content around this topic in bite-sized video tutorials. That's my number one focus, and then blogs. And then I'm going to share all of these ideas that I shared with you, but I just wanted to get a pulse of the audience. But we're going to skip this poll for the time right now. So thank you very much for attending. I hope if you're a Java engineer, you feel that you don't have to forget all the knowledge that you've trained, and you can use your skills in the AI revolution and become and upskill yourself as an ML engineer or Java machine learning engineer. This is my email. I'm going to drop this. Please feel free to check this bit.ly out. I'm going to put it here to show you first what it is. It's nothing. It's a very simple form where you can put your name and contact information. I'm only going to use it for my book that's coming out, and I'm going to share some blogs and code sample and tutorial in the process till the book is launched. So we can see now the training is complete here. It's still happening. Generally, it takes time. If it wasn't happening on the GPU, it would happen faster. One thing I'm gonna let's see if I have any questions at this time. Anyone has any questions or on the chat?
I cannot see any questions here under this section.
Yeah, so yeah, please, if you have anything, you can ask me. I don't know how much time we have.
Yeah, you are the last today, so we are not so in a hurry.
Okay. Maybe I can show you quickly. One other thing that I wanted to show you is another project, which is serverless function. Open recent. Yeah, this one. This is, I think I mentioned this earlier. I have to start Docker for this. So there are two ways to do microservice, like the way I see two popular ways. One is you Docker app. Okay, starting Docker. One is to use a framework like Helidon or microservices, and the other one is to do is is to use serverless function. And you may have heard of Amazon Lambda, right? And Oracle Cloud Function, it's the exact same thing. But what we have also done is created the Oracle Cloud Function, where you can run functions on the cloud, function as serverless technology uh, in the open source. And this is the project, FN project. It's an open source container native serverless that lets you run anywhere, cloud on premise, for various languages, including Java. So let's just, let me show you this thing. The Docker is running, okay. FN build. So I've installed this project called FN Toolkit, FN, and it's this open source function, and it has the CLI, very helpful to help me to build. And here, what I've done is this. So when you, so I have this just one class where I've defined. This is my project. This is my Java project, POM XML file. And all I have installed here is the FN project. And it has various libraries, and these are the several dependencies that I've installed. And I'm going to execute this. So, and what I want to do, like I said, this could be a function on the cloud where all it does, it's, you can use it for any kind of prediction, right? The image recognition. Now, if you don't want to have a full-blown app, you can just use this function. So in this case, I don't have a machine learning library here, code, but I could, another class that would be the TensorFlow one, let's say, and this function that calls the prediction from the TensorFlow. Right now, I'm just going to hard code predict this function, but it may as well come from, let's say, if I had another class that did the actual model inference. And then we can, I think we just do fn deploy. Fn deploy, yeah, like this. And I can deploy it right now locally. Fn server. Sorry, give me 1 second. Start. Okay. First, I had to start the server for the serverless project. Generally, if you're doing it on the cloud, you don't have to worry about that because it's all taken for you. All you have to do is just deploy your function. And that's what I did here. I've deployed the function, and the function gets deployed in, I'll show you. It gets deployed through a Docker container. And this is where the function lives. It lives in localhost. This is the endpoint that your client would invoke. So let's go here. Oh, okay. Sorry, this is not a GET request. We're gonna make a POST request, and we're gonna use this thing. Let's use this thing. Let's use command line. So here, I just made a post. I'm not sending any data, but right now the code is written that handles post. So basically, you can send JSON. So the post could be a text from input, or it could be image, or it could be anything that you want to run the ML model on, and the model will return you some kind of prediction. And this is just a template. It's just showing you what it would do. But here you can imagine that here you could do TensorFlow, TensorFlow that run model, and it would return the prediction that would be stored here. But I haven't defined this, so this won't work. So, but this would be your another class where you define what this thing does, where you import TensorFlow library, like I showed you earlier in your POM XML file, and then you run the model there, right? So the beauty of this is that there is no main method here. This is not a full-blown Java project, right? A Java app. All this project does, it calls this function, handle request. It's a serverless function as a service function, right? And this handle request is right now it's calling, it's invoking these. I have these static classes because it's really, you want to think of this as like one function that does something. And for not to make it a big project, I'm just using static classes here. So yeah, I hope that helps. It's another way of doing machine learning on the cloud. And that's all, folks. You can reach me out, ask me more questions. I'll be happy to answer. You can check out some of the GitHub projects. I put some of those things out there more fleshed out. And follow me on social media. I'll be putting more content there. With that, thank you very much for your time.